Hello, Algebra 2. This is going to be our last lecture. Is this the end? At least for lectures, it is. New material, at least. Just want to cover some things that will be on the final, but I didn't harp on it too much thus far in the review, so I just want to make sure that we're on the same page as we know what it is. Absolute value. Absolute value, it's the little bouncy one of all of the equations. It makes things go bounce, goes down, and then goes back up. Best way at the bounce one. Bounce. It kind of has the same principle as the squaring and square root. So if you have something square root, it gives you a positive. But then if you were to square root it out of that, you have to give me the positive and the negative. The absolute value, say, of a negative x is still going to give me a positive number. But if I were to reverse an absolute value, you're going to give me plus and negative. For the life of me, I cannot find what the inverse operator of absolute values is. There's a decent amount of reading that I went through that explains that it has to do with it not being an inverse function, blah, blah, blah. I wouldn't stress about it too much. Just know that you do need, it acts the same as squaring and taking the square root of something that's squared. That being said, let's do some graphing of an absolute value problem. So, as we go from old school, y equals the absolute value of x plus 2. Let's go back to charting it out, plug some numbers in, and see where we go. So if at 0, you're going to have 2. At 1, you have 3. Well, that's just going to go positive. So at negative 1, you have 1. Negative 2, you have 0. Negative 3, we have 1 again. Negative 4, we have 2. It bounces back up. So doing that logic, we're going to go from our 0th at negative 2, and it goes this. It bounces and goes, and it shifts to the left by 2. That looks familiar. Gee, I wonder if that has anything to do with shifty logic. And it really does. It's a transformation of a graph. It's exactly like the parabola. So, spoiler, this should be easy. Graph these two. I'll let you do them yourselves. Pause the video if you need to. But you should know where your vertex is, which is the opposite of the x in the inside. So 4 and 5. Bring out 4 and go up 5 right here. And we're just going to go bounce up. And we're on this one, it is going to be negative 6 and not 5, 3, negative 3. That is negative 6 down 3. Let me do this. And up. There you go. Absolute values. Hopefully you got that. The fourth shape that we could have gone over, but we never did, was the hyperbola. Hyperbola, in all fairness, you will rarely ever see that in the real world of applications, but it does exist on your final. And I want to just check that box and say that, hey, at least I talked about it so you have some familiarity of it. It might reoccur in other classes, maybe, but I want to at least say that we've covered it. The standard form of a hyperbola is going to be x squared over, this is centered at the origin for the record, x squared over a squared minus y squared over b squared equals 1. Or the flip of it, where you have a negative 1. I honestly don't love this form of how it's written. What I will suggest for you to have written is down here in green. My general form is going to be either this one or this one. You're paying attention to what is going to be on what is positive and what is negative. The key difference between an ellipse and a parabola is there's a negative sign. There's a minus sign. So that minus sign makes a big deal. Either you're going to have a negative x's, or you're going to have negative y's. There will only be one that of the two that will be negative. If you have in this, if you notice in this one, I have negative x, so what's left is I have positive y, and that positive y is going to show me what vertex I get, what are the vertex I'm going to get, and it's going to open upwards and downwards. With a positive x, I'm going to open on the x sides and go right and left. My vertex are going to be x's. Follow the positives. Follow the positives. That's the best way I can explain it. Follow the positive. When you have a positive y, you have y vertices, which are going to be the same locations of how you had figured out when it was an ellipse. If you have a positive x and a negative y, follow the positive. You're going to have your x vertices. You find it the exact same way that you had figured out with the ellipse, the shifty ellipse. Find where the origin is, or not the origin, where the center of the ellipse is, and then you shift it over by the distance of, if it's the y case, shift it the distance of b. If it's the x vertices, you're shifting at the distance of a, positive and negative. Let's try one out. Hey, which one's positive? X or y? My y's are positive. So let's do some numbers. My a is going to be 3. My b is going to be 1. My center is going to be 2 and negative 4. Which one was positive? It was the y. So I'm going to have y vertices. If I have a y vertices, that means I know that my x's aren't going to change. So I at least can plug those in at the moment. And I'm going to have my y. Oh, I wrote that wrong. My centers are 2 and 2. So I know that I'm going to be shifting from negative 4 and the distance of b, plus or minus b, which is 1. So if I were to minus it, I have negative 5. If I were to plus it, I have negative 3. My asymptote, I did not harp on in the tutorial. There are 2 asymptotes. Remember, asymptotes are the line that shall not be crossed. So those are our limiting factors. Those are the dashed lines that you can see right here. Dash, 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 dash. Dash, 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 dash. Those dashed lines, the parabola will get close to it, but will never actually touch it. None shall pass. Maybe I should have put a picture of Ganondorf. I don't know if you would get that reference. Never mind. Moving on. The way you get that formula of what the slope of that asymptote is going to be b over ax and negative b over ax. Think algebra 1, rise over run. You have your b over a, just positive and negative. So my asymptote for here, what is my b? My b is 1 over 3, comma, negative 1 over 3. So let's sketch what we know. I like sketching the asymptotes first. I'll do it in red because those are the things that cannot pass. Our center point is going to be 2 and negative 4. So we're around this space. My asymptote is going to be a 1/3, so not quite perfectly diagonal, but kind of wide. It's going to be a flattened line. So over 1 up 3, something like this, something like that. And because I know it's going to be my y vertex, that goes up and down. So going up and down, I have this at 2, negative 5 right here, and 2, negative 3 right here. And it's just it kind of looks like a parabola, but it's really not technically. And there you go. That's how you draw it. Next one I want you to do, if you need to pause this video and do it yourself, please do it yourself. Otherwise, unpause. Here we go. A is 2, B is 4, my center is -3, plus 1. Remember, I'm finding it from here and here. And I'm finding my A and B. This one is from here. This one is from here. My vertex, what is positive? It's going to be my x. So my x is positive. That means y stays the same. Well, I have -3 plus or minus 2. So in the minus, it's -5, and the plus, it's -1. My asymptote is going to be b over a, so 4 over 2, which is just 2 and -2. That's my slope. So let's figure out where my asymptotes are going to go. Find my origin, or not my origin, my center, which is -3 plus 1. This is where the center is, and it has a slope of 2. So something like that. 2. So I know that this is in the x, so it's going to be opening left and right. And I can switch my colors to get that point. -5, 5 and 1, and -1 and so it's like this, opens like this. Yeah. Do you have to write the asymptotes? It's extremely helpful if you did. So please do. The degree in which case I'm testing you for the final, it's a multiple choice. I'm not actually going to ask you to draw it. I'm asking you to match it. But it's good to know this because you might need it in the future. In real life, no, absolutely not. You'll never ever reoccur this. But it will be on other classes. Good luck. Graphing inequalities. Same thing as you do with your regular equal signs, but with an inequality, you're going to have some shading to do, whether or not you want to shade on the inside or the outside of the object that you're drawing. So illustration that I'm given here is that in this x squared plus y squared is less than 9, we know that this is a circle because they're both x and y are both squared and the coefficients are 1, the same. So it's a circle at the origin with a radius of 3. R equals 3 because we have 9. Now, if that would give you this little circle. Oh, because it's a less than and not a less than equal, it's a dashed line, as you can see. The way to check which is the truth of it is I would choose easy numbers. In this case, it would be 0, 0. Is 0, 0 greater than 9? Is that a true statement? Absolutely not. So this point right here cannot be valid. That means we would shade the rest of the point. Okay. Hopefully that makes sense. Let's try this. I have a little step-by-step. Solve to a form you want. Generally speaking, I like my shifty forms, so get those forms. Standard forms as best you can, or vertex forms. Write the equation to equal sign. Just, you can skip that step if you don't like it. It just helps to reference how to graph stuff. And so let's get this into a shifty. This is going to be a parabola because I have one that is not squared and an x that is squared. So that's a parabola. I want to complete the square to get this into the form, the vertex form. So let's -3, -3. I have y -3. Give myself some space. Is less than x squared minus 4. What is my secret number that I need to add on both sides? 4x for the record. There should be an x here. I will update that on the... Yeah. Your version should have an x. Okay, so -1. what's my b over 2 squared? I have 4. 4 divided by 2 squared is 4. Plus 4 plus 4. Over here, I'm going to go y plus 1 is less than x. I should write the x minus 2 squared. You can do the diamond method, yes, but you can also know that you create this perfect square, which would give you x minus 2 squared. Minus 1, and I have y is less than x minus 2 squared minus 1. So my vertex is going to be 2, negative 1. 2, negative 1 is 2, negative 1. This point right here, because I'm dealing with a less than and not a less than equal to, it's going to be a dashed line, and everything's positive, so I should have a happy face. It's really hard doing dashed lines on here. So let's check a space, a point that is valid. I really like easy points, but 0, 0 is on the outside of this, so let's check 0, 0. When this is 0 less than negative 1? No, that is not a valid statement. Because it's not valid, it can't be on the outside. It has to be on the inside. So let's highlight the inside. This is what you get. All right. Next problem. I'm giving you a circle in standard form, so that makes it pretty easy for you. Your C should be 1, negative 1, and your R is 3. So 1, negative 1 is this location with a radius of 3. These are my points. It's a greater than, so it's a dashed line. That's the object. Let's see if this turns into be a true statement or not. I would just plug in my center point, because that zeroes everything out. If you plug in at 1 and negative 1, this becomes 0 squared plus 0 squared is greater than 9. Is that a true statement? Absolutely not. So let's shade the outside. All right, next one up. These are all for you to do, so pause the video as you deem necessary. I will finish them so that you have that as record, but I want you to practice yourself. Here we go. My A's are gonna be 2, 3. My center is gonna be negative 4 and negative 2. My vertices are going to be, I'm gonna put my negative 2 here, negative 4 here, negative 4 here. This one is negative 4 plus or minus 2, so that is negative 6. This is negative 2, 2, okay. And then this one is negative 2 plus or minus 3, negative 5, and 1. Yeah. So my circle is going to be at the center, minus 4, minus 2, and it has this point and here and here, going up is 3, and here are they dash, or are they, this is equal, so this is actually a whole circle or ellipse, because it's less than or equal to. That being said, let's check my, I check the center because that turns all of this into a 0 squared. Plus 0 squared. Is 0 less than 1? Yes, it is. So we can just highlight the center inside. All right, that's all you. You do this problem. As it goes, pause if you need to. Otherwise, I'm going to complete the square and complete it twice. Square, rearrange all my x's together, give myself some space. Y squared plus 2y, give myself some space. Less than 5, which then, oh, if I'm not mistaken, this was supposed to be a 6. So it's 6. I know that because I retyped it. So this is going to be a plus 9. That's what my b over 2 squared is. So that's plus 9. And this is going to be a plus 1. Plus 1. That gives me 16. That's why I wanted it to be a 6 in the first place. This is going to be a perfect square of x minus 3. This is going to be a perfect square of y. Squared plus, this should be plus 1 squared less than. So my center point is going to be -3, -1. Same as going over here left and then down 1. There's my center. My radius is 4. That's point here, point here, point here, point here. This is a dashed line. And let's check if these from the center, is it 0? If it's going to be shaded in or out. So 0, 0, less than 16. It is. It's going to be on the inside. So let's shade in that inside. Cool. All right. I'm curious how you would draw this one. We had just covered hyperbolas, so I would leave this to you. I would pause the video and let you solve this yourself. Otherwise, it is 2 and 5, my A and my B. My center, my H is -6 and 1. Which one is my positive? My Y. My Y's are positive. So that being said, I'm going to keep my X's the same and have 1 plus or minus 5. And that gives me -4 and 6. Positive 6. My asymptote is going to be 5 over 2 and -5 over 2. I don't know yet what I'm going to be shading inside or outside. I guess I can do that one actually right now. So inside, outside, if I plug in from the origin points, that would give this to be 0. 0 is greater than or equal to 1, which is not true. It's going to be shaded on the outside. Let's draw my asymptotes, which is go up 5 over 2, something like this. Up 5 over 2. Something like that. My vertices, oh wait, take all of that back. I did it from the origin. Not supposed to do it from the origin. Let's try that one more time. From -6 plus 1. So at this specific point, I'm going to go up 5 over 2, and I get something like this. Up 5 over 2, and again I get something like this. Alright, that's my asymptote X, and let's draw in the points that I can, where my vertex are. I know that it's positive, so I'm going to have something that goes up and down. My points I need is -6, -4. So this point right here. And then -6, +6. Something right here. And it goes like this. They look kind of like double parabolas, but they're really not. They're different. That's mathematically different, but they have some similarities. Last but not, so those are the new materials. Um, how to shade things. Oh, we still have to figure out what the shading is. It's on the outside. So my outside, my outside, this is my center point, and it doesn't actually fit this one. So it's everything the opposite of what it'd be. This spot is. It's kind of confusing when I say outside or inside, but in this case, the center point, which was right here, does not get shaded. So everything is on the opposite of that. It kind of makes sense to me. Okay, last but not least, just reviewing. There's no work here. This is just me boiling down everything that I can think of from Unit 6 and Unit 7 into one single page. It is one single page. I will let you read over this. If you have questions, please ask. It is very much straightforward as needing to know how to identify exponential growth versus exponential decay. If the base is greater than 1, awesome, you're going to go to the moon. If the base is less than 1, then you're going to get a decay. Exponential properties, go Mario. It's the whole big world, little world, outside the exponent and inside the exponent. Changing exponent form to log form and vice versa. Y equals base x power can also be converted into log base b of y equals x. Log properties, you can cover that. Log rules, this one I really want you to focus on because that one people struggled with the most probably. And then just be able to identify this. Not gonna lie, if you can cover this single page, you'll score probably more than 50% on the final. 50% of the final is this page alone. So study this. If you want to make this into a poster, by all means. These 5 things right here are critical to succeeding on the final. Know your parabolas, know your circles, know your ellipse, know your hyperbolas. There's really only like one or two questions on hyperbolas, and it's a matching part. So just identify a shape. Last but not least, thank you for being a great class. It's been a pleasure. Good luck on your final.